Okay. All right. So you have your equations here, and the big takeaway from this write-up is basically we do these statistics, okay? We get the mean, and the mean is kind of like the center point for our data points, okay? And the mean is the same as the average. And then you calculate the standard deviation. The variance is just kind of like a midway point for calculating the standard deviation. And the standard deviation gives you a sense of precision. So I think this graphic down here really kind of describes this a lot. If you have high precision, you have something like this guy over here, where all your data points are grouped together. It may not be accurate, right? So you might not have a mean value that's close to the one that you were going for, but you're getting consistent results, okay? So if you have a high standard deviation, you have low precision. Your points are all over the place. If you have a low standard deviation, you have high precision, but it's like a quantitative value for it. And then you have your percent error. And this is a value that describes how close we got to the value, how close our mean is to what we wanted it to be. Okay. So an example like here, you would have high accuracy, okay, which would mean you have a low percent error. Over here, you also still have high accuracy, even though it wasn't precise. So you have a low percent error. These would be examples where you had high percent error. You don't have an average that's anywhere close to what you were shooting for. Okay. And I say that because down here, when you're going to answer these questions, it asks you questions like which were the most precise or something like that. Okay. Which piece of glassware was most accurate? Your most accurate one is the one that gave you the lowest percent error. Okay. We can know that for sure because we're being quantitative. Which one was the least accurate? This is the one that has the highest percent error. Which one is the most precise? That's the one that has the lowest standard deviation. So you kind of get that idea. This is what you would have been filling out in person, right? But you wouldn't really know what to put in here, right? So what you get is if you come back here, there's this student data here. If we open this up, and whenever it feels like it wants to load for us, it's going to do it, maybe. Here is the data that you would have gotten for while you were in class, right? These are the measurements that you would have taken, okay? And basically, all the other values that you're going to have are going to be calculated. So I want to go back to that other sheet and talk about where, let's put them side by side. Okay. So the first part is going to be this guy right here, right? And this is pretty easy. I mean, this is just this data, right? You just can copy that right over there. So that's pretty easy. And then there's the picture here. I usually have somebody sketch out a little picture. I think that it kind of like cements it in your mind what it is and stuff. And there are pictures of each one next to it. So that's what they all look like right there. So I provided you guys with those little sketches. You know, I think it's worthwhile doing. If you didn't do it, then I probably just wouldn't care. I get that that's a little silly when we're online, but you know, you could make me happy. Next is the water temperature. Okay, so that's pretty clearly right there. Then the question is, where are we going to figure out, how do we know the density of the water? And what it is that the density of water changes with the temperature. So if you come up here, right, so your water temperature is 25 degrees. There's this table here of the density of water at different temperatures. So you go to 25 degrees, and that's the density that you're going to use right there. And it's got its units right there in grams per milliliter. The other thing I do want to see you guys doing is putting in your units, right? So don't just write 25 here, right? 25 degrees Celsius, write the grams per milliliter there. It's always number space unit. It's something that you guys should kind of get used to doing when you're recording data. The next is going to be the mass of the beaker, and then the mass of the volumetric flask. Again, you're just copying those over, okay? So you'll see here, you're given the mass of the water and the beaker, and that would be this guy right here. And then you're asked to calculate the mass of the water. And the mass of the water is going to be the mass of the beaker in the water minus the mass of the beaker. So you're just going to subtract this mass from all of these, and that's going to give you the mass of the water. Okay. The nominal value is the value that you meant to deliver with the appropriate number of significant figures. And that's what this table up here is about. So you know that a burette, you should have 2 decimal places. You wanted to deliver 10 mils with it. So this is 10.00, right, with the 2 decimal places. And I'm going to show you where that comes in later, okay? Then you calculate the average, and you're going to put that there, and we can talk about how to calculate the average, but I did put up a video showing you how to do it using Excel. Did you guys see that? Yes?
Yes, yes,
Okay. Was that useful?
it was.
Okay.
And
Do you-
it made it easier on doing the calculations that you showed.
Okay. Do you guys think that I started off at the right level for Excel, or were you guys like, I already know this introductory stuff about Excel and he's wasting my time?
It was good as a refresher for some of it, and then there was other things that were like, oh, I didn't realize
Okay.
Excel could do that.
Okay. Okay, good. So you're going to calculate the average and the standard deviations, and you're going to put that there. Now notice that this is going to be the mass. Okay, so this is going to be the average mass, and this is the average standard deviation, and we're going to do something different in just a second. Okay. And then you're going to continue to do that, and you're just going to do that same thing for all of these, but there is one that's different. So we have our volumetric flasks. Now, all these other ones, we delivered the water into the beaker, all right, and then we weighed the water in the beaker. Volumetric flask is different. Volumetric flask is TC. The water goes in the flask, okay? So now you're being given the mass of the water in this volumetric flask. There's no beaker involved here. So to get the mass of the water for this one, you need to subtract out the mass of the flask. That's where this guy comes in, okay? So for all of the first ones, we're subtracting the mass of the beaker, but for the second, that very last one, the volumetric flask, we're going to subtract the mass of the flask. Okay, and you can see that it actually says that here too. It says mass of water in flask. It doesn't say mass of water in beaker like the other ones. Okay, and this one used to be wrong, but I just fixed that yesterday when Frederick pointed it out to me. Thank you, Frederick. So that's how that's going to work for that. Now you come down here, and it's a little weird to some people because it's kind of asking you for the same thing, right? It's asking you for the average and the standard deviation. You're like, hey, dude, I already gave that to you up here, okay? But these are going to be the average calculated volume and the standard deviation volume, okay? So these have different units. These are in milliliters. So what you're going to do to get these is you're going to take each one of these average masses and each one of the standard deviations. You're going to divide it by the density that we had up here. Okay, so you're taking grams, you're dividing it by grams per milliliter, and then that's going to give you these volume measurements that we can put in here. Okay. And then you're going to calculate your percent error, and your percent error is going to be this value minus the nominal value for each one of your things. I think everyone you're doing 10, so it would be minus 10 divided by the nominal value. You always make it a positive, okay? So it's like an absolute value kind of thing, right? And then you're going to multiply that by 100 to make it a percentage. And then you're going to put that into here. And you can see that equation up here. I think I used the right kind of language for it. So we got our nominal value minus our experimental value. So the experimental value here is our average in milliliters, okay? Divided by the nominal value. These upright guys on either side, that's the absolute value, which means that it's always going to be positive. So even if we got into a situation where this numerator was negative, you're going to take the positive value and then you're going to multiply that by 100%. And I also showed that in the Excel, the little Excel demonstration, how to do that. And so then once you have that, you're just going to write out a little example of the calculations. You don't have to do it for all of them. You just have to do it for one. Just show me an example of each one of the calculations. And this really lets me to give you guys like all your partial credit and stuff, right? So I can look and see how you're doing the calculations and stuff. It's something that we really don't get much in the virtual, right? Because you guys aren't handwriting out quizzes and stuff. So it lets me kind of see what you're doing and give you some tips and some pointers to help you calculate things the right way and give you partial credit even when you have a value that's wrong, right? I can see where it is that you're making the mistake. I think that this is really important for this kind of learning, for you guys to at least have some assignments where you're working it out and showing me your work. So I want to see examples of those. You have to have units throughout. If you look at the homework that I give you guys, you'll see, good examples of how you should be writing out the problems with units and really spelling it out clearly and organizing your math well, canceling your units and stuff. So that's the kind of thing I'd like to see you guys start to be able to recreate on your own. And then we talked about this. So, the most accurate one is the one with the lowest percent error. The least accurate one would have the highest percent error. The most precise has the lowest standard deviation. The least precise has the highest standard deviation. And this question is really for people who did it in person. I understand that it doesn't make sense for you guys. I don't mind if you just skip it. If you see a question like that, I'm still cleaning this up a little bit for you guys. Don't get too hung up on a question that seems to be for somebody who did it in person. Okay, just do your best. I do want you guys to say something. You guys could say something about the difference between systematic and random error. Okay, for instance, if for one of them it was always just a little low, say it was always like a mil low, that's a systematic error. That means that it regularly is always low. Okay, whereas if you have one where all the points are just all over the place, sometimes they're higher, sometimes they're lower, there doesn't seem to be any sense to it, that's random error. And that's pretty much it. And then what I would like to see you guys do after you've filled this out, and also you have options for this, right? I get that not everybody has access to printing. So if you can't print these out, then you can just get a notebook out and just recreate this stuff in your notebook, okay? Just try and make it look like this as best as you can. And then you could take a picture of that. And you're gonna take some pictures with your phone is what most people do. If you could scan it, that would be fantastic. And then you're going to zip it all together into one file and you're going to upload it onto see the things in my way again. You're going to upload it for the measurement report here. So if we preview this, you see there's only one question. It just says choose the file. You're going to point it to the zip file that you made, and then you're just going to upload it there. Okay. If you can make it one file, and there's many ways to do that, you don't have to necessarily zip it all together. I just don't want like a whole bunch of, there's no way for me to like let you upload multiple files without adding more questions. And when it's multiple questions and it's every week for every student, it just becomes too much of a mess. I need a little bit more organized than that. Because I want to grade you guys all fairly and make sure you're getting all your points. If you don't know how to do the zipping, I also made a video about that here. And it kind of shows you how to do the whole zipping up thing. Is that what it is? So that stuff's down there. So now it would go like PDF, data, video, quiz, report. You like that better?
Okay, yeah, just to give us more
Okay.
of an
Well, Jamie,
organized.
you know what? You just saw it. It's like that now.
Okay.
I am the master of that. That just happened. Okay.
And then the additional resources, are those just to give us more of an example to
The
help us?
additional resources is
in it,
important. So
or-
the additional resources is important. The additional resources is what you get from me on. Okay. I want you guys to start off with the reading, which is why I put it up here, because I think that the reading is important. And I think that a lot of people like to skip it. And I really don't see that working for a virtual class. Okay. So I do put that up here because I want to see people do the reading. But the additional resources, you need to, yeah, you should get used to this because this is awesome. Actually, you guys get a lot from me here. So if you come in here, I have done all of the homework problems. And I mean, like, I really spell them out. You can see I do the color coding, I do drawings, I do little stuff here. And it just gets to be more and more as we get into more and more difficult content. So I'm really spelling out how to answer each and every single one. And this is really in a lot of ways better because I get to take my time and think through it really well than the chalk talk kind of stuff I would do up on the board with you guys in class. Okay. And it's a lot more problems than I would be able to get through in the time allotted in an in-person class. So that's going to be really good. You can work on the homework problems and then go check that. The next thing is the presentation. So this is a full PowerPoint presentation on this week's thing that I went through. Okay. So this would be like the equivalent of you guys being in lecture and I just PowerPoint presented it. Okay. And there are more hours of PowerPoint presentation in here than again, I would be able to get through in an in-person class. Okay. So you guys are actually getting a lot from me doing it virtually in that way. This PDF here is just a PDF of that PowerPoint that I'm going through in the video. Okay. Sometimes students just, they like to have the PowerPoint PDF. I don't know, sometimes they print it off, sometimes they make little notes on it as they're watching the video or something like that. It's just a little additional thing for you. And then in addition to that, I give you, that's most of what the additional resources are. But like, for instance, this week, it's nice to have a periodic table. There are a lot of them out there. So I actually went and got one that was specifically good for these problems. You're going to see that there are other periodic tables and little things like that I add in here. Sometimes I add like a little presentation, like I know in week 8, we're doing titration. And titration is just kind of tricky a lot of the times for people. So I did a whole PowerPoint presentation on titration just for the lab for that one too. So sometimes I add extra little things in the additional resources, but that's what that is. But yeah, so that's kind of the flow of it. So if I were you, what I would do is you want to do the reading, okay? You want to go through and watch my video if you have time in your week to do that, okay? Make an attempt at the homework. Check out the homework solution guide there, okay? And then you can start going at the quizzes, okay?